Hey guys, welcome to the math lesson 19, and we're also going to do lesson 20 today. This page can be found in your little math booklet that should be located in your binder. So today we're going to be talking about factors, prime numbers, and then also greatest common factor. So a factor of a number is a whole number that divides the number evenly. So in other words, it is two numbers that can come together and be multiplied to equal the number in question. So for example, if it is asking for the factors of 12, you can multiply 1 and 12 to get 12. You can also multiply 2 and 6 to get 12. And then you can also multiply 3 and 4 to get 12. So all of these numbers are factors of 12. Now when it comes to reducing fractions, these numbers are going to be coming in handy to us because we're going to be using the greatest common factor, which is a list of factors between two numbers. So I'll talk about that later. But for now, factors are going to be the two numbers that can be multiplied to get a number in question. Now, another interesting thing about factors is a prime number only has two factors to begin with. So, for example, 5 is only divisible by 5 and 1, which means in order to get 5, only 1 and 5 can be multiplied. So that is two factors. You have 1 and you have 5. So 5 is a prime number. 6, however, though, is divisible by multiple numbers because you can have 1 times 6, or you can even have 2 times 3. So for 6, you actually have 4 factors. So 6 is not prime. Now, another tricky part with this, though, is factors can actually be prime numbers. So, for example, we just said that 5 is not is not a normal number because it is prime, but 5 itself can actually be the factor to another number. Okay, so let's kind of put this into practice, and I think it'll make a little bit more sense. So list the whole number factors of 15. So the way I like to do this is I like to start with what I know to be true and do 1 times that actual number. So 1 times 15 I know equals 15. Can you guys think of any other ones? If you said 3 and 5, you are correct. So 3 times 5 also gives me 15. And that's it for now. Now notice I have a big old giant space, so I'm just going to get rid of that space and I'm just going to list out these factors, nice and neat, in my answer. So what I mean by a factor can have prime numbers inside of it, but prime numbers itself only has 2 factors. So 3 and 5 are both prime, but they are each separate factors of 15. So hopefully that makes a little bit more sense to you now. So let's do number 2. So list the 6 whole number factors of 18. Okay, so I know I'm going to have 6 factors of 18. So again, I'm going to start with 1 and 18. And then if you guys also said 2 and 9, then you're correct. Because 2 times 9 gives me 18. And then 3 and 6 are the last 2. Because 3 times 6 gives me 18. So there I have the 6 whole number factors that it takes to get 18. So I'm just going to write those neatly on my answer line. And again, I do have some prime numbers in that list, which is perfectly fine. Okay. Now the next one, number 3, lists the whole number factors of 21. So again, I know 1 times 21 gives me 21. And then I know 3 times 7 also gives me 21. And those are the only factors that 21 has. So this is where all those hours of studying your multiplication tables comes in handy. You need to be a pro at multiplication tables in order to do this. Okay, so I'm just going to write the answers on my line there. So again, 1 times 21 gives me 21, and then 3 times 7 gives me 21. Now, number 4, which of these numbers is not prime? So the way that I could do these is I'm going to list out the factors for each of these answers, and whichever one has more than 2 factors is the one that is not prime, which would be my answer. So 2, okay, what 2 numbers are the only ones that can be multiplied to get 2? It would be 1 and 2. What 2 numbers are the only ones that can be multiplied to get 3? It would be 1 and 3. 4, I know 1 and 4 can be multiplied, and then 2 and 2 can be multiplied. But I'm only going to write 2 once, since 2 and 2 are the same numbers, obviously. And then let's do 5. 5 only has 2 factors, 1 and 5. So the only one that is not prime would be C. So if you chose C, you are correct, because C actually has 3 factors instead of just 2 like all the other ones. And this little chart right here, guys, this was meant to be given to you, but obviously with the circumstances, I was not able to. But when we return back to school all together, I'm hoping that I can give this chart to you so you can tape it to your notes. But all these shaded numbers are prime numbers, okay, which means that they only have 2 factors. So I'm just going to write that to the side here. And if you want to, I will actually post these notes up for you, so you're welcome to actually look at this chart in closer detail and use them on your notes and your homework if you would like. Sorry about that, guys. I'm not sure what that was. So I will post a picture of these notes for you so you'll have access to this. Okay, so that is lesson 19 in a nutshell. So now we're going to move on to lesson